So this is M. Another, this is 2M. And look at their velocity. This is having I cap, J cap. So this, I'll write it U1 bar. Another is minus I cap plus 3 J cap. So somewhere, something like this. They're going to collide, and at the instant of their collision, the line joining the centers is parallel to a vector. Okay, now this is the t equal to 0. They'll move, they collide. So I cap minus J cap, I'm very sure. So it should be for, this will be 45 degrees. And the balls, what happened? They're going to collide. Okay, this is the one velocity I cap plus 2 J cap, no? So the velocity should be somewhere more towards y axis. This will be, yeah, this is the condition. This is mass M. This is 2M. I think, is that okay? I cap minus J cap should be like this. So this angle should be 45 degrees. So what can be that? Shall we call this a line of impact? Okay, now we'll resolve this. Perpendicular to this, we'll resolve it. Normal to that, and this will be tangential. This will be T cap. Which velocities will not change due to impact. Those which are normal component, those components which are along line of impact, they will change. Those components which are perpendicular to line of impact will not change. Okay, I'll bring the same. This is during collision, just before collision, just before collision. This is before collision. This is just after collision. I'll continue the diagram here, just after collision. Which components, the normal component will not change, V2N. Tangential components will be V1T, and this will be okay. Now you can see this. This was the whole diagram is this much only. So this direction will define it. So let this be positive. This is a line of impact already I wrote. Once again, I'm writing it. So we know that angle is 45 degrees. We have U1 bar, U2 bar. Quotient of restitution, how we define it. First, we'll define all the components. U1 bar, we know it. T cap is there, no? T cap is what? R. Anybody value T cap? T cap should be. We can assume the direction in like a. Is it okay? So it will have unit vector minus this line of impact will have minus I cap plus J cap. I think it's justified. Huh? You can define R bar like this or in this direction. Yeah, defined R bar in this way. I just took this particular direction. I think justified minus I cap plus J cap. If you, what I defined, yes, defined R bar like this, the line of impact. So t cap is what I define myself for my convenient. So this will be the direction of t cap. Okay, first we'll calculate the component of velocity, this one. So u1 parallel u1 parallel should be equal to how much it should be u1 bar dot t cap. So this should be equal to u1 cos theta 1. So rather than finding out theta 1, no, take dot product. That will be better. Similarly, u2 parallel should be equal to u2 bar dot t cap. Cos theta 1, if you want, you can find out. I think we needed that also. Yeah, similarly, this will be u2 cos theta 2. So therefore, cos theta 2 equal to, just in the vector form, I'm trying to define it. So this will be u2 parallel. We know u1 parallel and u2 parallel. So what is u1 parallel is equal to u1 cos theta 1 u2. So after getting this, now I can define u1 perpendicular. u1 perpendicular will be, this direction is perpendicular, this direction is parallel. u1 sin theta 1. So what we know cos theta 1. So from that I can bring the sin theta 1. Similarly, u2 perpendicular will be u2 sin theta 2. Okay, agreed. So this should be equal to what? Shall I write directly? V1. After this quotient of restitution formula, this should be equal to V2t minus V1t by U1 U1t minus U2t. Okay, we know all the values. So V2t and V1t are unknown. I'll get, so can we apply conservation of linear term along line of impact? Yes, one more equation. So that will be 2m U2t plus m U1t should be equal to 2m V2t plus m V1t. Solving these two, we'll get all the unknown quantities.
Sir, t cap should be equal to minus I cap plus j cap by root 2, no sir, not 2.
Root 2, huh?
Yes, sir.
Okay, yeah. I forgot. Yeah, okay. Thank you. Yeah. This is what I defined it. Huh? Yes. I made changes. Okay, some vector form. So just do remember the dot product also something somewhere thinking like this. Huh? If they directly give some sort of like velocities in the I cap, J cap, no, you can define coordinate axis and you can define the line of impact and work out the problem. T cap, you see this? This direction is what I'm defining it. This direction, tell me what should be the unit vector of this? Should have negative x-axis, positive y-axis, no? This direction. Okay, I think justified negative sign. No, not common normal, common tangent. T is tangential. Now tell me this direction, what it should be? Oh, I'm showing common normal. It is. No, common normal if you want, then n cap dot t cap should be 0. So then from there you should bring common normal. No, common normal will come in this direction. No, common normal will have positive. No, perpendicular to this. If you want, you can directly bring common normal also. I think it will be I cap plus j cap by root 2. Okay. What I wrote is t cap. If you want n cap should be I cap plus j cap by root 2, perpendicular to that. Okay, okay. You want common normal. Okay, that will come here. I don't have space. Now this n cap will be. Now even you can take help of this n cap and you can do the problem because n cap and t cap should be perpendicular. Common normal, common tangent. So some just vector approach is what slowly I want you to develop also. If they give information the vector approach, yes, you can do the problem using the vector analysis. If they give some speed angles, okay, you do that one. So which one is convenient, you can prefer that. Because why this is like even finding out this theta is not advisable. These things are not advisable. You can just manage with vectors only.